That's funny, I'm on an angle. All right, so today we are going to start talking about 7.4, which is shifted conics. Okay, so we refer to parabolas, hyperbolas, and ellipses as conic functions. And so up to now, we've always been everything's been through the origin, but we're going to move it away from the origin. So let's talk about the parabolas. We'll talk about the general form or the basic form, and then we'll talk about the shifted form. Okay. So the idea here is, maybe I should move this down a little bit. Now we're going to shift from the origin to some, well, I'm going to call it the center, although with the parabola, you don't really have a center, you've got a vertex. The center is going to be at H and K. Okay, so the basic form of the parabola that we've been using in chapter 7 is going to be 4py equals x squared. Okay, so if we're going to shift it from the origin, the idea here is whatever is in your, now I called it the center here, but it's really the vertex in this case. We're going to shift it in the, so here, let me put the shift in the opposite sign. Okay. So the idea here is if I have your basic form of your parabola is 4py equals x squared, then we're still going to have the 4p, but the y is now going to be shifted in the k direction. So it's going to be y minus k, just one minus is all I need, equals, and then in this case, x minus h quantity squared. Okay. And so it's going to work the same way with ellipses. Okay, and I'm not going to do every case, but I'll just show you the one. So basically, your basic form of your ellipse is x squared over a squared plus, oh, I hate that, plus y squared over b squared is going to equal 1. I'm going to move these all over just one cell just to make this a little bit easier for myself. Maybe I'll move this over too. All right, and then we'll underline these so they look like fractions. Okay, so the shifted conic is going to work basically the same way. I'm going to copy this so I don't have to retype it every time. Now, the main difference is now we're going to shift this as x minus h quantity squared, and we're going to shift your y minus k quantity squared. Okay. And so if we resize that, that's how your ellipses are going to work. And it's going to work exactly the same way for your hyperbolas. And I'm just going to copy this because it's going to make it a whole lot easier. For the hyperbolas, basically the only difference between the ellipse and the hyperbola is we're subtracting and subtracting. Okay. So that's the basic, this is kind of section 7.4 in a nutshell. So let's go ahead and we'll start doing a few examples here. So let's start with a parabola, okay? So let's say that I have x plus 1 quantity squared over 4, and I've got plus, oh no, that's not what I meant. Oh heck, we'll do this one instead. Let's do y minus 2 quantity squared, and that's going to be divided by 9 equals 1. Okay, and we'll underline that, and we'll underline that. We'll center those so they look a little better. Okay, so here's what I want to do. I'm going to copy this over to Paint, and we're going to do most of our work over here today. Okay. So first of all, I didn't underline that, but I meant to. Okay, first of all, what is this shape here?
An ellipses.
Okay, an ellipse. So what is it? It's an ellipse. Okay. Now, since we know it's an ellipse, where's the center? We'll find all the things. The center of the foci, the vertices. Is that it? Is that all I need for this ellipse? I think it is. Okay. If I remember something later, we'll add it. Okay. So what do you guys think for that? I'm going to draw my thing here. Okay.
Is it 1, -2?
It's actually the opposite. Remember, these signs are flipped.
Oh, right. Okay.
So it's going to be -1, 2. Okay. So if I draw that, that was a little bit low.
Do you always flip the signs when you find the center?
Yes.
Okay.
Okay. All right. So if my center is at -1, +2. Okay. So I'll put my center right here. Now everything is going to move based on that. So in the x direction, do I go up, down, left, or right? And how many from the center?
Left and right 2.
Left and right 2. Okay, perfect. So if I go 1, 2, and 1, 2. Okay, so I've got my 2 vertices. One is right here. One is right here. And then I'm going to go up and down. How many?
3.
Up and down 3. Perfect. Okay. So I'm going to go up 1, 2, 3. And I'm going to go down 1, 2, and 3. And so I will mark my new vertices. One's going to be right here. One's going to be right here. Okay. And so, except for actually, those are in the wrong spot, aren't they? How do I move that? Well, I'll just do it that way. Let's put them right here. And right here. Why is it using white all of a sudden? I say there, and I say there. Okay. So now I'm going to draw my ellipse. Hopefully it'll go through those points pretty well. That was pretty good. Okay. So there's my ellipse. So let's talk about the vertices. Where are the vertices?
±2, 0.
-2, 0. I don't see that.
Or
So So this point here, right here, is what?
That's gonna
This point right here on the bottom?
-3, 2. Oh, on the very bottom.
On the very bottom.
-1, -1.
So -1, -1. And on the top, I've got
-1, 5.
-1 and 5. And on the left, I've got
-3, 2.
-3, 2. And on the right, I've got
1, 2.
1, 2. Perfect. Okay. So I think it's really easy to graph these because then you just look at the graph and say, oh, that's where it is. Okay. Now the foci will be a little different. How do we find the foci? You guys remember?
So it'd be a squared plus b squared equals c squared.
That's what it is for the ellipse, or excuse me, for the hyperbola, but not for the ellipse. So for the ellipse, remember it's c squared equals a squared minus, or actually I should say, the big number squared minus the small number squared.
So 9 minus 4.
Exactly. So c squared equals 9 minus 4. So therefore, c is going to equal the square root of 5. Okay. Now remember, the foci are always on the major axis. And so if I were to draw here where they were, square root of 5 is a little bit more than, so the square root of 4 is 2, so it's a little bit more than 2. So we're measuring it from the center. We're going to go up a little bit more than 2. And we're going to go down 1, 2, so it's going to be just below the x-axis, okay? So what are the coordinates for those two red dots there? So in both cases, we've gone back -1, right? Okay. In both cases, the x-coordinate is -1. Now we're measuring it from the center. The center is at 2, and then we're going to add or subtract the square root of 5. So those are your coordinates. Does that make sense?
Mm.
Does it make sense to you, Hallie?
Yeah. So the square root of 5 goes in the y because 9 is bigger than 4, and that's the major axis.
Yeah, the y direction is the major axis. And so
Okay.
you're going to measure it from the center. So you're going to go up the square root of 5 from the center, and you're going to go down the square root of 5 from the center.
Okay, that makes sense.
Okay. All right. So any questions on that one?
Can you go over how to find the vertices one more time?
Okay, so the easiest way to find the vertices, so the center is critical. So everything's going to be measured from the center, okay? So once we have the center, in fact, I will box the center here, because everything's going to be based off of where your center is, okay? So now in the x direction, you're going to go the square root of 4, which is 2. So in the x direction, we're going to go 1, 2 to find that vertex. And then we're going to go 1, 2 to find that vertex.
Because it's plus or minus 2, right?
Right. In the y direction, we're going to go plus or minus 3. So from the center, we're going to go up 1, 2, 3. And from the center, 1, 2, 3. So once you have that, now you just can eyeball and look at where the vertices are. So this point here on the bottom is -1, -1. This point on the top is -1, +5. This point here is -3, +2. And this point here is +1, +2. Does that make sense, Landon?
Absolutely. Thank you very much.
Okay. So I think the graphs are going to be critical to drawing these, even though in some questions it may not ask you to graph it. It's going to help a lot, I think, if you do. Okay. So let's do another problem here. And let's say here that we have x squared minus 4x equals 8y minus 28. So my first question is, maybe I should put this above. What is it? What do you guys think it is?
Parabola.
It's a parabola because
Because of the x squared.
yeah, we've got a y equals an x squared. Okay, so it's definitely a parabola. Okay. Now, ideally, if this was in an ideal situation, we would have some sort of an x minus h quantity squared equals 4p times a y. Oh, man, I'll just leave that. No, actually, I don't. Y minus k quantity squared. Okay. So the idea here is, how can we make the left side? We need to make it look like an x minus something squared. How can we do that? Any ideas? I'm going to give you a hint. I'm going to move this to the right. That's your hint. Why would I move that to the right? I'm also going to move this out of the way because it's kind of blocking my view.
Are you going for a perfect square?
Yes. How would we find the perfect square?
It's 1/2 of b squared.
Okay, so yes, so half of 4, which is
2.
2. So we're going to add 2
4.
squared, which is 4, right? So if
Right.
I add 2 squared here,
You got a -4 there.
no, I need to add 4 here as well.
Oh, right, yeah.
If you add it to one side, you need to add it to the other.
Yes.
Okay. So essentially what this becomes here is, we can factor this now through completing the square. This becomes x minus 2 quantity squared equals 8y, and then -28 plus 4 is -24. Okay.
I just have
And
some
go ahead.
quick clarification. So you took the -4x and you did half of that and you squared it and added it to both sides.
Correct.
And then what did you do from there to get x minus 2 squared? And then
Okay, so anytime that you so this is the technique. Do you remember what we called completing the square? So
Yeah.
once you do completing the square, basically then you factor the x, you factor the 2, and then whatever this sign is, if it's a plus or a minus,
Oh,
you're
right.
going to copy that, whatever that sign is, as the sign.
Mm-hmm.
Okay.
Okay, thank you.
All right. So now we've got x minus 2 squared. Now this is almost in our nice form right here that we wanted, right? Okay. So now I've got, I need to factor the right side. And so in this case, I'm going to factor the right side. So here, I'll just rewrite the left. X minus 2, quantity squared equals 8 times y minus what?
3.
3. Okay. So now we've got it in the form that I wanted it in. So now we're not going to call it the center this time. We're going to call it the vertex. But where is the vertex?
+2, +3.
Exactly right. 2 and 3. Okay. So and then the other things that we're going to want to know is where is the focus? Where is the directrix? And heck, let's find the lattice rectum while we're at it. Okay. Now, at this point, I think it's good to draw it, because you know me, I like to draw graphs. Okay. Now, we've got a vertex at 2, 3, so if I go 1, 2, 1, 2, 3. Now, this is going to be my vertex. I'll put a little circle there just to keep that as a placeholder. Okay. Now, how do I find my focus? Well, I could here. I'm going to finish drawing this, I think. I don't know, maybe this might be a bad idea, but I'm going to draw my parabola. It's going to look something like that. Okay. Where's my focus? I feel like I asked that in every class. Where's your focus? No, just kidding. Here's a hint. We need to find out what P is in order to find our focus. What's P? Somebody said 2. Who said 2?
I did.
Who's I?
Andrew.
Yeah. Say Andrew did, or Hallie did, or whoever. Okay, so P equals 2. How did you get P equals 2, Andrew?
Well, 4p equals 8.
Yeah, exactly. So it's going to equal whatever that is right there, the 8. Okay. So 4p equals 8, so p is going to equal 2. So your focus is going to be 2 units up, and this is where drawing is going to help me. If I go up 2 units, 1, 2. Now this coordinate here, whoops, well, I drew a line there. I meant to draw a circle. But that point there is your focus. And so what's the coordinates of that point?
Wait, did you
2.
just go? Sorry.
Go ahead and ask your question, Hallie.
Sorry. Did you just go up 2 points from the center?
From the vertex, yes.
From the vertex, yeah. Okay.
Okay. So the coordinates of the focus are now
2, 5.
2 and 5. Okay. Where's your directrix? Any ideas?
2, 0.
Okay, so remember directrix is not a point, it's a line.
Would it be a 1?
So when you say it's a 1, you mean it's this line
Yeah.
right here? Wow, I drew that almost completely straight. That was amazing. I never do that. Okay. Okay, so what is the equation of that line?
Y equals 1.
Y equals 1. Perfect. Now, how do we find the coordinates for the lattice rectum?
Wait, really quick, how did you get the direction says y equals 1 and not y equals -2?
Okay, so remember the relationship between the vertex and the focus is up 2 units. So the relationship between the vertex and the directrix is going to be down 2 units. And so if I go down 2 units, it's going to be at the y equals 1 line.
Oh, I see.
Okay. All right, so now what is the relationship between or how does the lattice rectum relate to the focus? As I just said, this distance here is P between the vertex and the focus. What is the distance between the curve and the focus?
2p.
2p, okay? So that means I have to go over 1, 2, and so I didn't, let me think here. My scale isn't very good. But so if I go over 2, so if this is 2, so 2 times 2 is 4. So I need to go over 4 units. So 1, 2, and I need to draw in 3 and 4. Wow, that actually looks like I drew that pretty good. And so my lattice rectum should be here on the left side. And then I need to go 4 units to the right over here. 1, 2, 3, and 4. 4 units to the right. And then if I draw my little circle here for my lattice rectum, I did a pretty good job with that. Okay. Better than I did in my first class. So what are the coordinates for the lattice rectum? Must be Joey's turn.
Is it -2, 5 and positive 6, 5? Like between those two?
6, 5. I think so. If we can
correct?
count.
1, 2, 3.
So the -2,
Yeah.
5 is definitely correct. 1, 2, 3, 4, 5, 6. Yes, they're both correct.
Okay.
Okay. Well done. Does that make sense?
Did you go left and right 4 from the focus?
Correct.
Okay.
Okay. All right. So now let's do one more. We'll probably run out of time if we. Let's see here. What is. Let's say that I just give you an equation here. Let's go with blue. The equation, maybe I'll do it this way. 9x squared minus 72x. Here, I'm going to put a gap here. Minus 16y squared minus 32y. Whoops. Oh, I need to make sure this is all in one line. Come on. There we go. 32y. I'll put another big gap here. Equals 16. Now, why do you think I put those big gaps there?
You're going to complete the squares.
We are going to complete the square. Okay, now this one's a little bit tricky because I do not have a 1x squared or a 1y squared. And in order to complete the square, I have to have that. So what I am going to do to make it a 1x is I'm going to factor out the 9 out of the first 2 numbers here. So this becomes x squared minus, let's see, 70, that's 8x. Okay. And then I'm going to leave a gap here. And then what do we add here to complete the square?
Four squared.
We're going to add 4 squared, okay, which is 16, okay? But the problem is it's not just 16 because I'm taking that 16 and I'm multiplying it by 9. And I've done enough of these now that I know that what I'm really doing, so I'm really adding 144 to the left side, which means I need to add 144 to the right side as well. Does that make sense?
Mm-hmm.
Okay. Now I'm going to pull out the 16. I'm going to be left with y squared minus 2y. And what do I need to add, excuse me, to complete the square?
Uh, 1 squared, so 1.
So I need to add 1 squared, but I'm really multiplying that 1 times a negative 16. So I'm really subtracting 16, which means if I subtract 16 on the left, I have to subtract 16 on the right as well. Okay? So essentially what this becomes is basically I've got 9 times x squared plus 4 quantity. No, I don't want to do that. Get rid of that. X plus 4 quantity squared minus 16 times y minus 1 squared equals, in this case, the 16s are going to cancel, and I'm going to be left with, come on, a 144. Does that make sense? Okay.
Mm-hmm.
Now, at this point, I didn't ask at the beginning because I wasn't sure, but what is it now? At this point, we should know what it is.
It's a hyperbola
Why is it a hyperbola?
because they're both x squared, but they're going to end up being fractions to make it equal 1, and it's x squared minus y squared.
Yes, perfect answer. Okay. So I need to divide the whole thing by 144. Divide, whoops. Divide, divide, divide. Oh, why did it do that? It just went to white for no reason. Divide, okay? And so in all 3 cases, I'm going to divide by 144, 144, and 144, okay? So what do we get on the first one?
It's over 16.
You've done this enough times, you know those now. X plus 4 squared divided by 16, and then minus what?
Y minus 1 squared over 9.
1 squared over 9. That equals 1. And we'll try to underline both of those. Oh, having a really hard time today. Underline and underline. Okay. All right. So now, okay. So at this point, we can probably start graphing things. Okay. I'm trying to decide. Oh, I think I'll graph it down here. Okay. Now let's start talking where our center is. So the things we need to know for the hyperbola: the center. I didn't mean to underline that. The center, the vertices, the foci, and the asymptotes. The asymptote's going to be a little bit tricky, but we can get it. Okay. The center is probably the easiest thing. Where's the center?
-4, 1.
Center is at -4, 1. Okay. So let's go ahead and draw that on here. -4, 1, 2, 3. I wish I had something. 3 and 4. And +1. So I've got my center here. Okay. Now from the center, am I going up, down, left, or right, and how many? Maybe I should talk about the transverse axis too.
Yeah.
What's your we probably should answer that question. What's your transverse axis?
Is it going to be, it's going to be on the x-axis because that comes first.
Yes.
And we're going to be
It's
going left and right.
parallel to the x-axis. Okay. Yeah, so we're going to be going left and right. That's exactly right. Okay. So we're going to be going left and right. How many?
4.
We go left and right 4. So 1, 2, 3, 4. That's going to put us right on the axis here. And then we need to go 4 to the left. 1, 2, 3. Ah, you stinker. 3 and 4. Okay, so then I can draw that there. Okay, so that's your transverse axis, and now your, I don't want to call it, it's not really, it doesn't have a name, but we'll call it the minor axis. We're going to go up and down how many?
3.
Up and down 3, 1, 2, 3. So 1, 2, 3. So now I can draw my little things here and here. Okay. Now I can draw my box. So if I draw my box here, then I'm going to draw my asymptotes that go through the new center. Okay. Now my hyperbola is going to be right along like this and like that and like this and like that. Okay. Now, okay, so now we can see where our vertices are. So where are the vertices?
-8, 1.
-8, 1, and
0, 1.
0, 1. Okay. The foci, how do I find my foci?
It's here, C. So it would be plus or minus 5.
Squared equals a squared plus b squared, right?
Mm-hmm.
So c squared equals, in this case, 16 plus 9. That was lucky. So C is going to equal 5, right?
Mhm.
Okay. I'll put that in a different color like green. So we're going to move 5 from the center. And if I grab my circle here, so 5 from the center is going to be 1, 2, 3, 4, and then 1 unit to the right is 5. I also need to go 1 unit to the left here. So 1, 2, 3, 4, 5, and it's going to be right here. And so what are those coordinates?
-9, 1,
And
then 1, 1.
1, 1. Perfect. Okay, now the asymptote, this one gets a little bit tricky. Okay. So we've got x squared first, so that's going to be, so normally our asymptote would be y equals plus or minus b over a times x. That looks a little funny, but that makes sense. Okay, so in this case, we're going to move our asymptote, and it's going to be y minus, in the x direction, 3 equals negative b. So negative b is going to be 3 over 4 times x minus, oh wait, is that right? That's not right. My center is at 4, negative 4, 1. So y is going to be y minus 1 equals, and then I've got my b over a, which is going to be 4 over 3. No, it's going to be 3 over 4. 3 over 4 times x minus negative 4, which is going to be x plus 4. Does that make sense? And that's perfectly fine. I would rather you left it like that than moved it all around. So the asymptote on that hyperbola is a little bit tricky. Okay, but basically, it's the same thing, y equals plus or minus b over a, but now you have to take into account where your center is, and your center is at negative 4, 1. So it's going to be y minus 1, x plus 4, and then you have your b over a that works the same as it always did. Okay?
So if your x and y's were actually no, never mind. Never mind, I got it.
Okay. All right, that was a good one, huh? It's a good review of all of chapter 7. So I'm going to work on getting your quiz up right now, and then you guys got any questions before I let you go? Okay. So quiz tomorrow will be on 7.4, and then we will start on chapter 8. So that'll be a lot of fun. So see you all tomorrow.
Thank you.
Mm-hmm.